Hello everyone, welcome to today's class. In this lecture we'll discuss some important properties of adjoints and inverse. Okay. The questions that can be asked can be directly on these properties. Mostly it's like you'll get 4 statements A, B, C, D, and they'll ask you to find which one is correct. So you should have the idea regarding the properties of adjoint as well as inverse. Second way, they can slightly give you some value of some determinant and ask you what will be the positive determinant of adjoint or what will be the possible determinant of inverse. So again, the properties are still very straightforward. So just go through them directly. Okay, let's look at this. First, let's have a look at adjoint. Okay. Adjoint. So the first property is A into adjoint A. If you multiply them, it is pretty much same as adjoint A multiplied by A, and it is equal to mod A times I. Okay, A into adjoint A is same as adjoint A into A is equal to mod A times I, identity matrix. Remember, we are not talking about determinant of it. We are multiplying two matrices. One is A, one is adjoint A. So whether you multiply A with adjoint A or adjoint A with A, it's same. Okay, and it is equal to mod A means determinant of A times identity matrix. Okay, that's the first property. Second. Okay, the second property is suppose you do adjoint AB, adjoint of two matrices AB. This can be broken down as adjoint B into adjoint A. Okay, means you want to distribute adjoint regarding this multiplication of AB matrix. You can, it's just that you have to reverse the order, and this is pretty much the same idea that we discussed in transpose also, like AB transpose. We learned this, that why during multiplication if you want to split even the transpose, you have to change the order. So same thing pretty much here. Okay. And same thing will be happening in the inverse also. Okay. Okay, next we have adjoint of A transpose. Okay, this is same as adjoint A whole transpose. So whether you do the transpose first and then calculate the adjoint, or you do adjoint first and then transpose it, it is same. Next property, adjoint into adjoint of A. Okay, means first you calculate adjoint of A, then you again calculate adjoint of that matrix. Okay, so adjoint of adjoint A, that's mod A times n minus 2 into A matrix. Okay, all right. Next property is that suppose we are calculating determinant of adjoint A. Okay, this is determinant of adjoint A. I have put the mod, but I explained it that mod means it's a symbolic notation for determinant effectively. This is directly equals to mod A raised to power n minus 1. Okay, I have introduced n here. What's n? If in case anyone is wondering, n is the order of matrix. So it's a 2 cross 2 matrix, so n will be 2. If it's a 3 cross 3 matrix, it will be 3. Okay, let's look at the next property, sixth. Adjoint bracket adjoint A. This is what we calculated now. Suppose you ask the determinant of this. This is the maximum that they can go for. Okay, so adjoint of adjoint A, determinant of that is equal to determinant of A raised to power n minus 1 whole square. Okay, remember n minus 1 whole square is there. So these properties they can be directly asked. That's why I'm discussing this separately. Okay, now let's look at the properties of inverse, then we'll discuss few questions based on this idea. Inverse. Okay. let's look at the inverse. First of all, if we define inverse, how we used to define it, that AB if you multiply, okay, and it results in identity matrix of nth order, and whether you multiply BA, so you multiply any matrix, you multiply A with B or B with A. In that scenario, if it generates identity matrix, then B is A inverse, first thing, okay. Second thing, A inverse exists. This is something we have talked about in inverse also, but I'm still making them in the properties as such. A inverse exists if determinant of A is not equal to 0, okay. Sometimes it is written like this also. A inverse exists if A is non-singular matrix. Sometimes this word comes along, singular matrix, okay. Now what is the meaning of non-singular or singular effectively? So I'll add this word, singular matrix. What is singular matrix? It implies that the determinant of the matrix is 0. So that means for A inverse to exist, determinant should be non-zero, means A should be a non-singular matrix. So sometimes a question comes to find the value of x so that the matrix is non-singular or singular accordingly. So you can find, if it's singular, solve it equal to 0. If it is non-singular, then it is the determinant should not be equal to 0. Okay, next. What if you do inverse twice? Means you calculate inverse, again calculate the inverse of it. So it cancels it out and effectively you get the original matrix back. So A inverse is A, okay. All right. Next, singular we have talked about, okay. Then A inverse you already know, that's adjoint A upon determinant A, that's we have already discussed, so I'm not writing that again. But one property that during the multiplication, AB inverse is, if you want to split the inverse along the multiplication, you will have to reverse the order. It is B inverse A inverse, or if it is A B C inverse, then it is C inverse B inverse A inverse, okay. 5. Next, suppose you have to calculate the transpose inverse. So what you can do is you calculate the inverse first and then do the transpose. Means order you can change, whether you do transpose first or inverse first won't affect the result finally. Next, if you want to look determinant of A inverse. Sometimes this is asked very straightforwardly. What is determinant of A inverse? That is nothing but 1 upon mod A, okay. Means whatever was the determinant of A, you do the reciprocal of it, that is the determinant of A inverse. But don't try to deal this with thinking that A inverse means 1 upon A. No, there is no such thing as 1 upon A, okay. All right. And one more property, sort of theoretical sense again. This is something if you can recall in the paper, that will help, unless and until if it is directly asked. It depends what kind of questions are created. That inverse of symmetric matrix is also symmetrical, okay. So if you do there is a symmetric matrix, I hope you recall what is symmetric matrix, whose transpose is same as the matrix itself, okay. So if you do inverse of a symmetric matrix, the inverse will also be a symmetric matrix, okay. All right, this pretty much covers all the properties related with the adjoint and the inverse, okay. Every single property is very important, make a note of this, okay. Now let me put up the questions and I'll add one more property additionally. Sometimes this is not with anything adjoint or inverse. It's like, suppose you multiply any matrix with K and then you calculate the determinant. that becomes k raised to power n determinant of A. Okay, this is a property of determinant, but it's a separate property. It has nothing to do with the adjoint or inverse. Okay, so if you multiply matrix by 2, the determinants get multiplied by 2 raised to power n. N will be order of matrix again. Okay, if it's a 2 cross 2, it's 2 raised to power if you double each and every element, so it will be 2 raised to power 2 for 2 cross 2. For 3 cross 3, it will be 2 raised to power 3. Let's look at our question. If determinant of A is equal to, let's say, 5, then determinant of 3A is equal to, A is first part 2 cross 2, second part 3 cross 3. What if it is 2 cross 2, 3 cross 3? Let's deal with both. Okay, so again, this is direct application of this property, so I'll add it here. Okay. So this is the property. If you multiply any matrix with A, the determinants gets 3 raised to power n times. Okay, so determinant of 3A will be 3 raised to power n determinant of A. Now for 2 cross 2, n is 2, so determinant of 3A is 3 raised to power 2 determinant of A. 3 raised to power 2 is 9, determinant of A is 5, so that's 45. Okay. Then for a 3 cross 3, 3 cross 3, it implies n is 3, so determinant of 3A, 3 raised to power 3 times A, so that's 27 into determinant of A is 5. It will result in 5 to 10, 135. Okay, that's the direct application here. Same question, I'll add third part. 2 parts are done. So let's say third part. Find determinant of A inverse. Okay, so for determinant of A inverse, it will be so we know that determinant of A inverse is 1 upon determinant of A, which is 5. So answer is 1 by 5. Okay, let's add another part here. If one second, let me look at the formula, then I'll frame the question accordingly. Okay, so if determinant of A is still 5, okay, find determinant of adjoint A and determinant of adjoint of A for 3 cross 3 matrix. They can ask for 2 cross 2 also, you vary your n accordingly. So adjoint A determinant is determinant of A power n minus 1. So 5 raised to power 3 minus 1, so 5 square, that's 25. So we don't have to do anything, it's all about knowing the correct property. Okay, next adjoint of A. Okay, adjoint of A, determinant of that is mod A raised to power n minus 1 whole square. So 5 raised to power n is 3 minus 1 whole square. So that is 5 raised to power 3 minus 1, 2 square is 4, 5 raised to power 4, that's 625. 525, 125, 625, yeah, correct. Okay, all right, this is done. What else they can frame? multiplication done, this is done. A into adjoint A, no? So same fifth part I'll create. So if again same mod A is, let's say 5, then adjoint of adjoint A is equal to let's say k times A. Okay. Find k if A is 2 cross 2, first part. Let's do both the parts. Second part, 3 cross 3. Okay. All right. So for this 2 cross 2, 3 cross 3, let's look at the property. So A is adjoint of adjoint A, that is mod A raised to power n minus 2A. So this is our k. So what is mod determinant of A mean? So 5 raised to power n minus 2. So for 2 cross 2, that is 2 minus 2 times determinant of A is A basically. So 5 raised to power 2 minus 2 is 1A. So for this k is 1. Okay. And for 3 cross 3, same thing. It's just that this time you will write 3 minus 2, n minus 2. For 3 cross 3, you will write 3 minus 2 times A. So that is 5A. So k is 5. Rest everything is same. Adjoint bracket adjoint A is determinant of A n minus 2A. Okay. So these kinds of questions can be created. They are very simple, very straightforward, as long as you know all these properties. Okay. Inverse, remember that whether you do inverse of AB or adjoint of AB or transpose of AB, the order always gets reverse. Okay. Fine. That's it. This was a very small topic, but yes, this was very important, and a very direct questions can be created on this. So do go through these properties, make a note of this. Okay. All right. That's it. This is what I wanted to cover for this lecture. So short lecture. I hope you like this. Okay. And more importantly, they are very much relevant from examination point of view. All right. That's it for this lecture. See you in the next class. Good day, everyone.